evening and welcome everyone. What we'll be doing tonight is revising key parts of the course using strategically chosen short exam type questions. And throughout the webinar, tips and tricks to get the most from your Nspire and efficient solution methods will be offered. And I recommend that you have your questions in front of you to get the most from the webinar. Okay, the first lot of questions deal with the functions and algebra areas of study. So the first question, so this is a maximal domain question. So the maximal domain of the function down there. Now, it's the sort of question that many students will be able to answer just from their knowledge of the logarithmic functions. However, using Nspire, you can be absolutely certain that you've got the right answer, because built into Nspire is a domain command. So the domain command allows you to enter the rule of a function and it will automatically return the maximal domain of that function. So how do you access domain? Well, you have to go to the catalog. So the catalog is the book symbol, and make sure that you've got tab number 1. If you're not on tab number 1, then you just press the 1 key, and then if you press D, it takes you to the top of the D. If you press E, it takes you to the bottom of the D, and you see there domain. Now, if you look down the bottom of that dialog box, you'll see the syntax. So it's domain expression. So the expression is the expression for the rule of the function, and the variable, which is usually x, so comma x. Okay, so there we have it. We press enter and we get negative infinity to 1. So we see that if you have a look at your answers, it corresponds to answer D. Now also note that the way that Nspire gives you the answer might be different from the options in a multiple choice question. So you need to be aware of equivalent expressions. So obviously x between negative infinity and 1 is the same as the interval for option D. Okay. So question 2. Now, this question is also a gift. Now, the first one was a gift because using your Nspire, you can be guaranteed to have the right answer. This one is the same. This is, you've got a rational expression, 2x plus 1 over 2 minus x, and we want it expressed in that other form, and we want the values of p and q. Now, when this question was asked a few years ago, almost half of students got it wrong, and of those that got it right, many spent a lot of time doing polynomial division, whereas in fact your Nspire will guarantee that you got the right answer, because there's a proper fraction command. Now, to access the proper fraction, it's menu, algebra, and down there you've got fraction tools. And one of the options is proper fraction. And it's just proper fraction, put in your expression, and it gives it to you in the required form. Incidentally, the expand command does exactly the same thing. Okay, so proper fraction, you put in your expression, press enter, and you get that value there. So which of those options is it? It's actually option D, which is a bit counterintuitive. If you look at that, it looks as though you've got a -5. Once again, be aware of equivalent forms. Note that the Nspire doesn't give the denominator as 2 minus x, but rather as x minus 2. So in fact, the value of q is +5. So once again, be aware of equivalent forms of the expression. All right, question 3. Now, I'm moving through these fairly quickly because I want to get through all 20. So, inverse function. Now, there are two parts to a function. There's a rule, f of x equals something, and a domain. And you need both parts to have the function, and in particular, both parts to have the inverse of the function. So for this question, we not only need to know the rule of the inverse, which you can do by swapping the x and the y, but also the domain. So the original, you can think about the original function as being y equals f of x. So the inverse, you're swapping the x and the y, so you can think of that as being x equals f of y. So if we solve for y, that'll give us the rule for the inverse, although that's only one part of the inverse function. Okay, so we can start off by defining the function, and we want to swap the x and the y for the inverse. So we don't want y equals f of x, we want x equals f of y, and solve that for y. Let's see what happens. All right, so we get an expression, we get an equation for the inverse. So we can see what the rule is. Now we could have, of course, we could have done that by hand, easy enough to do by hand, but with the Nspire in exam 2, it's just a way of double checking that you're absolutely correct, because it's very easy to make a minor mistake when doing things by hand, and you don't want to lose marks in the exam. Okay, now, so that's one aspect. I've got the rule, and which you may have done by hand anyway, but you can confirm that that is in fact the rule. So I can now graph that. So if I hit the tab key or the Control G, I can see that f1 of x is just my f of x, which I've defined. Now, to get the graph of the inverse, if I go to F2, if you then hit the delete key, you can delete the equals, and you'll see that it gives you other options. So you can put in inequalities, and option 6 is relation. So you're out of function mode, you're now in relation mode. So you can enter a relation which can either be a functional or a non-functional relation. In particular, you can enter x equals f of y. And bingo, you've got the inverse. And if I want to change the color of that, just touch it, control menu, that's control menu to get the context menu, color, and you can change the color. All right, so we can see that the domain of the inverse is R+, or positive reals, and with the y-axis being an asymptote. So that becomes pretty clear. So if we then look at the options, then the option must be D. Now, what if I'd had a different domain restriction? What if instead of it being the original function was only defined from negative infinity to 2? To get the domain of that function, all I need to do is put in that domain restriction, x is less than 2, and we can see that the inverse now has a new domain, which is from 0 to 2, rather than from 0 to infinity, from 0 to 1, rather than from 0 to infinity. Okay, so next problem, functional equations. Now, students find these quite difficult. As we can see, that one that was asked a few years ago, 53% of students did not get the correct answer. So Nspire deals quite well with equations. So let's have a look at, rather than a functional equation, to see how Nspire deals with these, let's have a look at a numerical equation. So I want to know whether that equation is true or false. So if I press enter, false. So that is never true. What about that equation? Square root of 9 plus 4 equals the square root of 13. I press enter, it's true. It is always true, whereas the first statement or the first equation is always false. What about if I have another equation? So the square root of x plus y equals the square root of x plus the square root of y. Is that always true, always false, or is it only sometimes true? So let's press enter. And we see that all it does is it just returns the input to you. So if it doesn't say true or false, if it's any other output, usually it's just the same expression returned to you in the same or a different form. It means that it is sometimes true, but not always. So in this particular case, that third equation is true in the trivial case when either x is 0 or y is 0. So I can do the same thing to answer a question like 4. So I start off, I define option A. So option A was, is that equation true? Is that functional equation true for f of x equals 2x? So I define the function, I put in my equation, press enter, and it just throws it back at me in a different form. So that is not always true. So that is not the answer. That's probably only true in the trivial case, not in general. So I can go back here. So I can then go enter that. I can edit that equation, and I can edit that to option C, for example, which is I define f of x equals 1 over 2x. Option C. I then go back to my equation. I don't have to type it in again. Press enter. Enter again. It's true. It is always true. So that is clearly the right answer. Okay. So the answer is C. It is true for all real numbers, or all non-zero real numbers, x and y. All right, question 5. So this one involves simultaneous equations. So for those two equations, when will that system of equations have no solution? So these are a common type of question. No solution, unique solution, infinite solution. So I'm just going to have a small animation here just to illustrate when it is that it might have no solution. So here we see that we have a unique solution. We see a single point of intersection. But somewhere around there, around about negative 3.16, the two lines are parallel. So there is clearly no solution. I keep going. It's a unique solution. We can see a point of intersection. But round about there, we see that once again, the lines are parallel. So there are a whole multitude of ways of solving these questions. One of them, of course, is to say, well, they're going to be parallel when they have the same gradient, so easy enough to do by hand. One technology-assisted approach that you can use is to go to Menu and Algebra, Solve System of Equations, and just enter your two equations. Okay, so that just, you get the template coming up, you put in your equation, press enter, and you see that that's the value of x and the value of y in terms of m. So then ask yourself, when does that value of x and y not exist? Well, it's clearly not going to exist not going to be defined when m squared minus 10 is 0, because division by 0 is undefined. So m squared cannot equal 10. Or another way of looking at it, there's no solution when m is positive root 10 or negative root 10. Or another way, sometimes the question asks, when does it have a unique solution? Well, it has a unique solution for all r except for root 10 and negative root 10. Okay. Question 6. So this is just a straightforward trigonometric equation, solving a trigonometric equation, but increasingly the examiners often ask for the sum of the solutions rather than listing the solutions, so that so as not to give any hints. Otherwise, students can often work out which of them it must be without doing any working just from the option. So by having the sum, it's a way of not giving too much away. Now, with these questions, when you want the sum of solutions, you can use, instead of the solve command, use the zeros command. So the zeros command is in the, whoops, wrong page. The zeros command is under algebra, and you see zeros. Now, zeros works a bit like solve, except that instead of having one equation equals the other, you have an expression equal to 0. So I have this first bit minus the next bit, which will equal 0. But you don't need to put in the equal 0. In fact, don't put in the equal 0, because it's what you're working out. You're working out the zeros. So exactly the same as the solve command, but no equals. Just have an expression that equates to 0. And the domain restriction the same way. And you get the 4 solutions in a list. Now, the reason why that makes it easier to then find the sum is that you can then go get sum. You can get sum, S-U-M, from the catalogue, but it's much quicker to just type it, the sum, and you just go up to that list, press enter, it pastes it in, press enter again, and bingo. 2 pi on 3 is the sum of those solutions. So the answer is B. And you can see that that's a lot easier to deal with than using solve, which would have x equals this or that or that, and then the sum of those is not as quick. And of course, in the exam, every second is gold. All right, so last one in this set, we want the transformation of this function. So you start off with a reflection in the x-axis, followed by a translation of 2 units to the right, followed by a dilation from the y-axis by a factor of 1/3. So one of the ways that you can use Nspire to help you with these, now these are easy enough to do by hand, I guess, but Nspire, if you start off by define the original function, so a reflection in the x-axis, which means that gx becomes negative gx after the reflection. Your positive y values become negative y values. And what I'm going to do is store that as g1 of x. So it's a new function g1 of x, which is a transformation. If I now want to know what the rule is, I actually don't need the intermediate steps, but if I needed them, just find G1 from the var menu, G1 of X, and that's the rule after it's been reflected. Okay, now next I want a translation of 2 units to the right. So I had my G1 of X after my first transformation. So now my x values become x minus 2 values after I've done a translation 2 units to the right. So that's now stored. Once again, I can, if I want to see what the intermediate rule is, there it is there. And lastly, a dilation by a factor of 1/3 from the y-axis. Now, a dilation from the y-axis, I need to divide by the scale factor. So I divide by 1/3, and I can get that back, and there's my answer. Now, that doesn't correspond, as written, it doesn't seem to correspond to any of the answers, any of the options, but of course it does, because there is option A, 9 minus 12x minus 3. So obviously, if you expand under the square root sign, is your answer. Okay, so that's the end of the first set. Next set of questions, which involve calculus. Now, I apologise for going through this quickly, but I want to get through all the questions in the hour. All right, so in this case, I've got this function g of x is k over x squared minus x. There is a stationary point on the graph of g when x equals 3, find the value of k. So a stationary point at x equals 3. Now, if I have a stationary point, then I need the derivative of g of x to equal 0. Now, a way of saving time in the exam, use the shortcut shift and minus to get the derivative template. So let's have a look at that. You hit the shift and the minus, and bingo, there's the template in one fell swoop. Now, you know, that's a few seconds that you're saving, which is all good. So I need to find whereabouts the derivative equals 0, because the derivative equals 0 for the stationary point. Okay, so there it is in terms of k, and we were told in the question that the stationary point occurs at x equals 3, so we replace the x by 3, and we solve, which of course you could do in your head, but while you've got Nspire, you might as well do it there just to make sure that you haven't made a mistake, and your answer is B. Okay, so there, remember that shortcut, and it's easy to remember that it's shift minus for derivative, because just remember that when you differentiate a polynomial, you have to subtract 1 from the power. Okay, question 9. So we've got this function, and a tangent to the graph of f has a gradient of -4 e to the minus 4. The tangent will cross the x-axis at. So the first thing, the tangent has a gradient of that. Now, the gradient of the tangent is given to us by the derivative. So I'm going to need the derivative equal to -4 e to the -4. Okay, so find x such that the derivative of f of x is -4 e to the -4. So now, because I'm going to use f of x more than once, it's worth defining. And I need the derivative, and remember, to get the derivative, shift minus, you get the template more quickly. So I press enter, and I get an expression. Sorry, I get an equation. I can now solve that for x and find the value of x, but there may be more than one place where the tangent has a particular gradient. So make sure that you include the domain restriction. Now remember, right at the beginning of the question, the function was x greater than or equal to 3 on 2. So we do that, and we find that this occurs at x equals 2. Now sometimes you'll get these warnings so that there could be more than one solution. I think you can be fairly confident that if the question is on the exam, that it would have been checked as part of the vetting process in developing the exam. So I think you can assume that the answer that the technology gives you is going to be the answer, the one that you're after. If not, the vetting process has broken down. Okay, so we know that it occurs at x equals 2. Now, in order to find where the tangent crosses the x-axis, we need to find the equation of the tangent at x equals 2. Now, if you go to Menu, Calculus, you have tangent line. Now, what you need to remember about tangent line is that it does not give you the equation of the tangent. It gives you an expression for the tangent line. Now, often, exam questions, especially in section B, the extended response, will ask for the equation of the tangent. So if you only include an expression, then you haven't answered the question, and in all probability you won't get the mark. So I always say, don't think of tangent line as an end in itself. Always use it in conjunction with y equals tangent line. And the syntax is the function, an expression for the function, comma, the variable, comma, the value where you want the function. So that's the equation of the tangent line. If you didn't have the y equals, it wouldn't be an equation, it would only be an expression. Now, in order to find the x-intercept occurs where y equals 0. So I replace the y with 0, solve for x, and the answer is x equals 3. So the tangent occurs at x equals 2, has that gradient at x equals 2, and then that tangent crosses the x-axis at x equals 3. So the answer is C. Okay, halfway through. Question 10, or almost. So we've got the graph of that function. The average value over the interval 2 to 14 is. Now, this question, this is very similar to a question asked back in 2014, and it's a conceptual question. It's a question where the examiners were trying to test whether you understood the concept. So there was no major calculation required. In fact, there's very little calculation required. So you need to understand the concept of average value. So average value is the average height. Now, here we've got a function which increases and then decreases at a constant rate. The lowest value is 2. The highest value is 7. So just using a bit of common sense, you think, well, halfway in between the difference between 2 and 7, that's 5 units. So 2.5 each way. So 2 plus another 2.5 brings me to 4.5. So just by inspection, without doing any great calculation, I reckon that the average is 4.5. Right? Another way of looking at it in terms of area, I've got the same thing here. So we want the average height of the function, in terms of area, see the area of the triangle here to the left of that line, and this yellow triangle here, those two areas have to be the same. And likewise, this triangle over here and the yellow triangle underneath, those areas are the same. And that's where the formula for average value comes from. It comes from trying to get the average, trying to get a rectangle that has the same area as the area under the graph. All right, so what we're trying to do is, let's stop working. So what you're trying to do is to get that yellow area to be the same as the area under the function. So that's 54 there. Going back here, the yellow area is 54. So you're trying to equate those two areas, trying to make a rectangle. So what height would you need for those to be the same? Okay, so in this case, the answer is 4.5, or answer B, 9/2. So that's a conceptual question. Did you understand the idea, where it comes from? The next question, also average value, but this time calculation is required. So I've got this function. The average value of f over the interval from -1 to k is 13/2. Find the value of k. Now, this time I want to get the integral template. Now, it was shift minus for the derivative template. For the integral template, it's shift and plus. All right, so let's have a look at that. Shift plus, and bingo, you've got the template in one go. All right, so this time I need, that's my formula for average value, and that has to equal 13/2. Okay, so I solve for k, 13/2, and make sure that you put the domain restriction in, and we get k equals 7. So the answer is B. So back here, what we're trying to do, so I've got, this is my average height, 13/3, and I can see that the area under the curve and the area of the rectangle, if I have k equal 1, doesn't work. But I'll change that to 7. Okay, and guess what? The areas are the same, 34.7, 34.7. In other words, this orange area above the average height is the same as the yellow area between the line and the curve, between the horizontal line and the curve. Okay. So question 12. Now, average rate of a function and average value of a function are often confused by students. So make sure that you've got it clear in your mind which the question is asking for. So average rate is just average gradient, basically FB minus f of A over B minus A, or Y2 minus Y1 on X2 minus X1. So what I need to do, I can define the function so that then I can just put in f of 3 minus f of 1, having defined the function over 3 over 1. Solve that equal to 1 for P and -3 over 2. So option E. So there, defining the function at the beginning makes it a little bit quicker. Okay, 13. A rectangle is formed using part of the x and y axes and a point UV on the parabola with that equation. Now, the maximum area of the rectangle is. Now, when a similar question was asked in 2016, 63% of students did not get it right, even though it's a fairly straightforward question. Okay, so here, think about, instead of u and v, think of it as x, the point on the curve as x and f of x. So therefore, the area of the rectangle is x times f of x. So using Nspire, you can start off by defining the original function, since I'm going to use it again, so that's handy. I can define another function, which I call area of x. You could call it a of x or area of x, whatever you like, which is x times f of x. Now, I know that for maximum area, the area dx must equal 0. Now, once again, I can use the shift minus to get the template. I solve the derivative of the area equal to 0 for x, and I get two answers. X is negative 2 root 3 or positive 2 root 3. Obviously, we know from the graph that's given that it has to be the positive solution, but that's not the answer. That's only the value of x where the area is a maximum. We can assume it's not minimum because the minimum is obviously trivial. The minimum area is going to be 0. So having defined area, I now substitute 2 root 3 and I get 8 root 3 as the maximum area. So that's option D. Okay, 14. So this time I've got a graph with the function f of x is 8 minus 2 to the x, intersects the x-axis at points P and Q, and also shown on the graph is the line segment joining P and Q. The area of the shaded region is. So it looks something like this. The first thing you need to do is to work out the coordinates of P and Q, which, given the function f of x equals 8 minus 2x, it's easy enough to work out in your head. You substitute x equals 0, and so you're going to get y equals 7, and you substitute y equals 0, so you're going to get 8 minus 2x equals 0, so obviously 2 to the 3 is 8, x is 3. Okay, so that's easy enough to do in your head. However, you can use Nspire if you want to make absolutely certain. So substituting, having defined the function, substituting x equals 0, and then solve f of x equal to 0, and you get your y and x intercepts. Now, having established those, we can then find the equation of PQ. Now, it's just y equals mx plus c, so you can certainly do that in your head. The line has got a negative gradient, and it's a rise of 7 for a run of 3, and obviously the y-intercept of the line is 7. So the equation of the line, perhaps I'll call that g of x, I've got there. So now, to get the area between the curves, I can use my shift plus command to get my integral template from 0 to 3 of f of x minus g of x, and there's my answer. So it's option C. Okay, and that brings us to the end of the calculus questions. All right, so I think I'll just about be finished on time. So mathematical methods, probability and statistics area of study, questions 15 to 20. So the first question is a binomial distribution question, similar to one that was asked in 2017, and 62% of students did not guess a similar question correct. So in this one, a discrete random variable x is binomially distributed with n and p is between 0 and 1, not including 0 and 1. If the mean and standard deviation of this distribution are equal, then the smallest number of trials, such that p is less than or equal to 0.015 is. So what we need to do is we need to find n such that p is less than or equal to 0.015. This is what we know. It's binomially distributed, so the mean is n times p, and the standard deviation is the square root of np 1 minus p. We're also given the information that the mean and standard deviation are equal. So we can equate those two expressions, the n times p and the square root expression, solve that for p, so we can find p in terms of n. And of course, we know that p times n cannot equal 0 because we were told that. So we need p to be less than or equal to 0.015. So in other words, instead of p, I can replace the p by 1 over n plus 1. I solve that for n, and obviously n, you can't have a negative number of trials, so n has to be greater than or equal to 65.6 recurring. Now obviously, because it's binomially distributed, it's got to be a discrete value, so it has to be greater than 65.6 recurring, so it's got to be 66 is the minimum. So answer D, at least 66. Okay, question 16. So this time it involves the normal distribution, similar to a question in 2012. So the lifespan of bright light car headlights is normally distributed with a mean of 890 hours and a standard deviation of 175 hours. The manufacturer claims that 35% of headlights have a lifespan of more than X hours. The minimum possible value of X is closest to. All right, so let's see what information we're given. We know that it's normally distributed. We know mean, we know standard deviation, and we're given that 35% have a lifespan greater than X. So if I call capital X the lifespan, the probability that X is greater than little, that lifespan is greater than little x is 0.35. Therefore, the probability that the lifespan is less than X is 0.65. Now remember that the inverse normal is from negative infinity to X, not X to positive infinity. So I need the area to be 0.65. So I go menu, oops, wrong page. So, no, still wrong page. I'm still in a notes page. Don't worry about that. Okay, so if I go to menu, probability distributions, inverse normal, my area 0.65, I've got my mean, I've got my standard deviation, and I get the answer 957 is option B, is the closest, because in this case it said is closest to. So that was a pretty straightforward question, and yes, about a third of students didn't get that correct a couple of years ago. And I suspect the reason is that students were using 0.35 rather than 0.65 as their area. All right, so a probability density function. Once again, these are fairly straightforward, but almost 38% of students didn't get a similar question to this correct just a couple of years ago. So you certainly can't take these for granted. So the probability density function of the continuous random variable x is given by, there's the function there, and note the domain 8 pi to 10 pi and 0 elsewhere. The value of k such that the probability that x is greater than k is √3 on 2 is. All right, so the probability that x is greater than k is given by the integral from k to 10 pi of f of x dx. Once again, remember your shift plus to get the integration template. So I need, because I've been told that the probability is √3 on 2, I can equate that to √3 on 2. I solve, making sure that I've got the main restriction, that it's from 8 pi to 10 pi. Absolutely essential whenever you're dealing with circular functions, because otherwise there tends to be infinitely many solutions, because it's a repeating function. And I get the value of k. So fairly straightforward question, and yes, it didn't have the success rate that I would have expected. So don't take these for granted. Okay, so the answer is B. Now, the next one now, dealing with a fairly new area of study. This has only been examinable since 2016, and that is the statistical inference for sample proportions. And it's an area of study, a topic that is causing quite a few difficulties to students. So assume that in a very large city, 50% of people named on the electoral roll are female. A sample of 20 names is selected at random from the electoral roll. For a sample of 20 names, capital P hat is the random variable of the distribution of sample proportion of females. You need to find the probability, or the probability that the random variable P hat is less than or equal to 0.3 is closest to. So in this case, the random variable for the number of females, not the proportion of females in samples, but the number of females in samples, is going to be binomially distributed, because either the person selected is female or isn't, with n equal to 20, p equal to 0.5. Now the sample proportion p hat is the number divided by 20. So the probability that p hat is less than or equal to 0.3 is the same as the probability that the number of females, not the proportion of females, but the number of females, is 0.3 times 20. 0.3 times 20 is 6. So it's the same as the probability that the number of females, capital X, is less than or equal to 6. Okay, so probability that X is less than or equal to 6. I can go to menu, probability distribution, binomial CDF. there are 20 trials, it's probably of success 0.5, and it's from 0 to 6. And 0.05765, blah, blah, blah. So the answer is B. So once again, the important thing, remembering that P hat is equal to X, the actual number, divided by the sample size. P hat equals X on N. That's all that was really required to get this problem right, and yet it obviously caused a bit of grief. Okay, so this is similar to one that was asked on the Northern Hemisphere paper last year. So a jar contains 25,000 jelly beans. Less than half the jelly beans are black. Random samples of 400 jelly beans are taken from the jar. Each sample is obtained by sampling with replacement. So capital P hat is the random variable of the distribution of sample proportion of black jelly beans. If the standard deviation of P hat is 0.018, then the number of black jelly beans in the jar is closest to. So for this one, you need to know the standard deviation of P hat, which is on the formula sheet. So we're given that N is 400, the sample size is 400, and the standard deviation is given by P, 1 minus P on N, where P is the true population proportion. All right, we know that the standard deviation, now in this case we don't know the true population proportion, but we do know the standard deviation. So I can find, so if I solve the formula for standard deviation equal to 0.018, I solve that for P, I can find the value of the true population proportion. Now, there are two possible answers, but we're told that half of the jelly beans are black, so it must be the smaller answer. All right, so that's the true population proportion, about 0.153. So to get the number of black jelly beans, it must be 25,000, the total number, times the proportion that are black, 0.153. So multiply that out, and it's about 3,825. So the answer is C. Okay, and we're going to be finished just on time, which is good. So question 20, similar to one that was given in the this year's Northern Hemisphere paper, which is available on the VCAA website, and students who do that Northern Hemisphere timetable sat this exam in June. So a researcher surveyed a sample of 640 voters in a large city and found that 416 supported a particular proposal. An approximate 90% confidence interval for the proportion of all voters in the city who support the proposal is closest to. So, same concept as the Northern Hemisphere question, obviously different answers in different contexts. Now, TI-Nspire will give you the confidence interval. So I want a 90% confidence interval. I know N, 640. I know X, that is the number of successes, 416. If I wanted the proportion of successes, it would be 416 over 640. But in order to use the confidence interval template, we don't actually need that. So you need to go menu, statistics, confidence interval. Now there's a whole lot of different types of confidence interval. You need a single proportion Z interval. So one proportion Z interval is the one you need, this one here. Okay, so I know X, I know N. The confidence level, so the confidence level is 0.9. And bingo, I guess my answer, that's the lower limit and the upper limit of the confidence interval. So the answer is A, 0.619 to 0.681. And I think I'm out of time, so thank you all very much.